So we're day 2, and remember we are in the unit circle? Yes?
Yeah.
Okay, so this unit circle, what's special about this unit circle? What's the radius? 1 unit. Okay, so 1 unit means that ratio of 1 unit. So when I do, when I do these, this is actually, sine is actually y over r. Okay?
I'm gonna write these down.
You should have written them down yesterday.
Oh, the y over r part.
I would probably add it to it if you can somewhere neatly. Okay, so y over r. But what is r in the unit circle? 1. So it's y over 1, which is just what? Y. Okay? And this is x over r. So it's x over 1. So it is x. So in the unit circle, that's how it became to be x. But it's really x over r and y over r. It's a ratio. Because if r is not 1, I need to put in what it is, don't I? Everyone understand what I'm saying right now?
Yeah.
So when we build our circle that I just gave you, or gave you yesterday, we're going to work on that next. We've got to remember that sine is y over r, and cosine is x over r. And hopefully you know all of those already because we wrote them a million times yesterday, and you should have written them at least 4 times each on your homework. Okay, so here's your circle. Hopefully my pen will allow me to write small enough to fit everything on there. If we are going too fast, you need to say something because I don't want you copying, I want you thinking. Does that make sense? Because when you copy, your brain shuts off, doesn't it? So get this paper out, get it ready to write on. You're going to hold it horizontally, and we're going to go. So it doesn't matter. Figure a top, figure a bottom. You're going to put it in your notebook, whichever way you want to look at it in your notebook. This is a tool. This is not a crutch. What's the difference between a tool and a crutch?
You can use it sometimes, but try and remember.
Right. It is a tool to help you learn them. If it's a crutch, you're staring at it all the time, and your brain is disregarding everything it gets off of it. Got it? Mm-hmm. So we are going to use our 30, 60, 90, 45, 45, 90 ratios that I told you needed to remember. And we're going to use the fact that sine is y over r, cosine is x over r, tangent is y over x, and the reciprocals of those. Okay, so we're going to put everything together today. So when I go around there, in here, we have a degree, and then we have another blank. What do you think the difference is? This is going to be a degree, and this is going to be a what? Radian. So before I start, this is what degree? 0. So it's 0 degrees. And how many radians? 0. And I'm going to jump over here. How many degrees is over here?
180.
180. And how many radian? Pi. So then what's up here?
90.
90 and
Pi over 2.
pi over 2 because it's half of pi. Yes?
Mm-hmm.
Okay. And then down at the bottom,
270.
270
And then 3 pi over 2.
and 3 pi over 2. Use the bar as a fraction. That's what I did.
Oh.
Or not. It don't matter. Okay, so I've got all those. But you notice on every single other angle there, I have also a degree and a radian, don't I?
Mm-hmm.
So we're going to figure that out. We're going to figure out what those angles are and how to fill them in. Well, if this is 90 at the top and this is 0 over here, well, this line right here is halfway, isn't it?
45.
Which is 45. And now, in radians, I'm not going to use the formula. We're done with the formula on this circle. The formula goes all the time, radians pi over 180 into degrees, 180 over pi. Everything but what's on this circle. What's on this circle, you're going to use your brain and what you know. Okay, so if I have a piece of pie, a chunk here, that is 45 degrees, how many 45 degree chunks can I get in pi?
4.
4. So this is 45 is pi over what? 4. Now, I can do the formula, and 45 times pi over 180 reduces to pi over 4. Because 45 goes into 180 how many times? 4. So I'm with the 45-degree chunks, yes? So I've got one 45-degree chunk, two 45, so it'd be 2 pi over 4, which reduces to what?
Pi over 2.
Pi over 2. And the next one would be what?
3 pi over
3 pi over 4. I love my 3. But I didn't talk about what angle that was.
135.
It's 135.
Which is 90 plus 45.
Right. Or you could also say it's 45 degrees away from 180. So 180 minus 45 would be what? 135. I'm going to direct all of our math to the x-axis, guys. That's our anchor point, okay? I am not going to do anything with the y-axis. Okay? So I'm going to direct everything to the x. So I've got 3 pi over 4. Plus another pi over 4 gives me 4 pi over 4, which is what? Pi. And then I'm going to go another 45-degree chunk.
5 pi over 4?
So it'd be 5 pi over 4. And it'd be 180 plus 45 is what?
225.
225. Oh, that's the degree one. Yes, I put it on the wrong one. It's 225 degrees. Do you see how we're building this? I'm not just telling you and you're not just writing it down. We are building it. We're going through the process so you know where all these numbers come from. So then I go another 45-degree chunk and I get 6 pi over 4, which reduces to what? 3 pi over 2. I go another 45-degree chunk and get
7 pi.
7 pi over 4.
Or 315.
And then I would take 360 minus 45, which would be
315.
315. Again, I'm going from the x-axis, right? And my degree over here is 360 and
2 pi.
2 pi. We should have already had that, I'm sorry. Now, if I took 2 pi minus pi over 4, would I get 7 pi over 4? Yes. Now, I'm going to say some things over and over and over and ask you questions, so I want to make sure it's clear to everybody, okay? So if I'm talking about 45 degrees being my reference angle, remember reference angle is the distance from the x-axis, yes? And I say in the second quadrant, I'm 1 less than a whole. So what's my denominator for 45?
180.
No, what's my denominator for 45 degrees in radians?
4.
4. So what is 1 less than a whole? 3. So it's 3 pi over 4 because I'm 1 less than a whole pi. So in the third quadrant, I'm 1 more than a whole pi.
5.
So it's 5 pi over 4. And in the fourth quadrant, I would say 1 less than 2 whole. 7. Because 2 whole would be 8. I will say those things. I'll say, remember, in the second quadrant, it's 1 less than a whole. So if my denominator is 6, 1 less than a whole is what? 5. If my denominator is 28, 1 less than a whole is 27. Everything in the second quadrant is going to be 1 less than 1 whole pi, isn't it? Because it's not quite there. Everything in the third quadrant is going to be 1 more. And then 1 less than 2 pi. It goes back to your reference angles. Okay, so we did that. Well, let's look. Let's figure out what this first line is. Oh, what do you think it is?
Would it be?
30.
It'd be 30. Why would it be 30?
Because it's not quite half, but it's
It's
not
1/3.
45.
Right, it's a third of it. And so if this is 30 degrees, how many 30-degree chunks can I get out of 180?
6.
6. So it's pi over what? 6. Now again, I can take 30 times pi over 180 and it reduces to pi over 6. I could do the formula, but isn't it easier just to say, well, 30 goes into 180 6 times? And a lot of times I'll just say 3 into 18. Yeah, it goes there 6 times. So now I'm doing chunks of 30 degrees, yes? I am not going to go around like I did 45. I'm going to jump over here. Just throwing things at you.
Yep. Thank you.
Okay, so if I go 30 degrees over here, so that means my reference angle is 30 degrees, doesn't it? Or pi over 3. So 1 less than a whole would be what?
5 pi over 6.
5 over 2.
5 pi over 6. Because my denominator is 6, yes?
Yep.
Okay, and then 30 degrees less of 180 would be
150.
150. Do you see how I'm referring you to the reference angle every time?
Yep.
That is our world, is reference angles. Because if you remember your reference angles, because these are that 75 points of the final that I told you about.
Oh.
But we learned if it has the same reference angle, it has the same sine, cosine, tangent, secant, cosecant, cotangent, right? So that means pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 all have the same numbers. It's just whether they're positive or negative that change. And that's it. So I took 4 angles and made it down to what? 1.
Well, technically 2 because you have positive and negative.
Well, but that's just based on the quadrant. It's going to be 1 absolute value, like they're going to have the same quantity every time. Okay, so then I need 1 more than a whole 30-degree angle.
7 pi over 6.
So it would be 7 pi over 6. And how many degrees?
210.
210. So then I'm going to go over to 2 pi, keeping my reference angle. So I'm going 1 less than 2 whole is going to be what?
11.
11 pi over 6. This is the one people mess up on because it looks funny. They say it looks funny because it goes into double digits. So 1 less than 360 is what? 330. But everything is 1 more than a whole, 1 less than a whole, 1 less than 2 whole. It is all about the x-axis. I said that enough so it sticks? So now we have 1 left. What do we have left?
We
60.
We have 60. Because if I look at my chunks, I have a 30 degree and then I have another 30 degrees, which would be what? 60? Okay, so this is 60.
It'll be 2 pi.
So 60 goes into 180 how many times? 3. So it's pi over 3. Now I want to do this 30 real quick and show you something. If I had 1 pi over 6 and this 2 pi over 6, what does 2 pi over 6 reduce to?
3.
Pi over 3. Okay? So we're 60 degrees away, pi over 3. When I hear 60 from now on, I should think pi over 3. That is what your goal is at the end of this thing today. 60 pi over 3. 30 pi over 6. 45 pi over 4. Why is it 6? Because 30 goes into 180 6 times. Why is it 3? Because 60 goes into 180 3 times. It's all about the division, the fractions, all those fun things. I told you fractions would not go away. They just get even more. So we got 60 degrees away from 180. It's going to be what degrees?
120.
120. And we're 1 less than a whole pi.
2 pi over 3.
2 pi over 3. I want you to do the last 2 quadrants on your own. CJ absent. Gotta fix that. Okay, who wants to tell us what the third quadrant would be? Evan, you can do 4.
It'd be 240 degrees.
How did you get 240 degrees?
It's 30 away from 270.
Nope.
60 plus 180.
Yes, it's
referring
60.
to the x-axis.
Thank you very much for fixing yourself. It is 60 away from the x-axis, so 180 plus 60 is 240. Okay?
And 4 pi over 3.
And 4 pi over 3? And how did
Because-
you get 4 pi over 3?
It's 1 more than 3.
Right, it's 1 more than 1 whole, and my parts are 3.
Okay, I'm getting so confused on the pies.
Yes, same.
On the what?
On
On the
the
pies. Like, I get the degrees, but in the
Okay.
pies,
on the radius.
So I have pi radian at 180 degrees, yes? So when we're doing this, we're cutting fractions. When I look at the denominator of a fraction, that is how many pieces make a whole, correct?
Yeah.
So 8 is 8 pieces make a whole. 4 is 4. 3 is 3. 2 is 2. Okay? So if I'm working with pi over 3, meaning there's 3 pieces in a whole, if 180 is a whole pi, and I need 1 more than a whole, so your denominator's 3, so 1 more would be 4.
How do you know our denominator is 3? Because our denominator was 6 right there and 4.
Well, because that was 30. Because 30 goes in 180 6 times.
Oh, so you just keep the denominator the same? as
Yes.
that. Okay.
When your reference angle is 60, your denominator is always what?
3.
3. Every single time. Radians, when you're talking reference angles, is so much easier. Because whatever your denominator is, that's what your reference angle is. When your denominator is 4, what is your reference angle every time?
4.
No, your reference angle is pi over 4, 45. So when you hear those two words, pi over 4, 45, those need to be interchangeable soon. Okay? But every time you see a 4 in the denominator, my reference angle is pi over 4. Every time I see a 16 in the denominator, my reference angle is pi over 16. So, does that help? Yes.
I'm getting confused on with 30 and pi over 6, and then you have 90 and then 3 pi over 6, which makes it half pi. I don't know. I'm getting confused on where you're putting the pies, I guess. I don't know 5 pi over 6.
Mhm.
How do you know if that's gonna be from 180 or something?
Okay, I know 5 pi over 6 is in the second quadrant. Is that what you're asking, where the angle is?
Yeah.
Okay, I know it is in the second quadrant because it's over half. Because if
But
it's
not over 1 whole.
it's not over 1 whole. It's over a half, but it's not a whole yet. So it has to be in the second quadrant. Because if it's half and the denominator is 6, then it would be 3 in the numerator, right? And since I have 5 in the numerator, then I'm over a half a pi. So then but I'm not quite to a whole because the denominator is 6, so a whole would have to be 6. So I'm in the second quadrant. Okay, Connor, fourth quadrant.
I have 300 degrees
Okay, how'd you get 300 degrees?
because it's 60 less than 360.
Right, 60 less than 360.
And I have I have 5 pi over 3.
Okay, 5 pi over 3. What's your reasoning behind 5 pi over 3?
It's 1 less than 2.
Right, it's 1 less than 2 whole. And if my denominator is 3, how many is 2 whole?
6.
6. So 1 less than 6 is
5.
5. Riley?
How would it be 5 pi over 3 if you need something to be 3 pi over 2? You know?
You don't need to, no, it doesn't have to be 3 pi over, 60 degrees does not land you, it won't land you ever at 270. It won't cut up that way. Does that make sense?
Yeah.
Like 60, this is how you know. Does 60 divide into 270 evenly? No. So 60-degree pieces will never land you at 270. It's okay not to land at 270. Yes.
Okay, so on that you took the denominator times 2
Right?
and then subtracted 1.
Yes.
Okay.
Yes. Okay, so what do you notice about the angles that I put on here? What are they?
There's
Well, the first quadrant, they're what?
the triangles.
They're the triangles. They are my special right triangles. So we are going to imagine putting in here, right here, a 60-degree triangle. That's 60. This would be a 30, 60, 90 if I put one right here, wouldn't it? Because this is 30. Yes? Okay. What ratio is opposite of 30 degrees?
30.
Remember your ratios?
Oh, yeah.
2
Is that 2 pi?
1.
No, 2 squared.
Isn't that 1?
It's 1. It's the smallest angle. It's 1, right? And it's 1A, but we're in the unit circle, so we're going to use what? 1. So opposite 30 is 1. Well, if this is 30 down here, this angle up here is what?
60.
60. Yeah, that's not a
That'd
60.
be 2.
So opposite 60, what's your ratio? Square root of
Square root of 3.
3. And then opposite of here is 2. Now, we're going to discuss this right now because people are going to say, wait a second, you said this was the unit circle, and the unit circle has a radius of what? 1. 1 unit. Got it? Our unit here is what? 2. That radius is 2. Okay? So when I do this, I've got x's and y's. So if I come over on the x-axis, how far is that? Square root of 3. And if I go on the y-axis, what is it?
1.
1. So that point is the square root of 3, 1, isn't it? Okay? But if I want to change it right now, it's square root of 3, 1. It's x, y. If I want to change that into sine, cosine, like we did yesterday, what do I have to put x and y over? Just gave it to you. What has to go in the r? What's r?
1.
What's r?
2.
2.
Oh, yeah.
Because of our triangle. So right now, this square root of 3, 1 is x, y, isn't it? Once I put it over 2, it's no longer x, y, it's cosine, sine. Because cosine is x and sine is y. Yes?
Yeah.
Everyone understand that?
Yeah.
So we just took a point and made it from the point xy into the cosine sine. Exactly what you had yesterday in your assignment.
Wait. Well, oh, because cosine equals x,
Yes.
so is that why you're calling it cosine sine?
Well, cosine is x over r.
So it's
Okay.
square root of 3 over 2.
So square root of 3 over 2. Because your radius would be your hypotenuse.
Okay.
Now, we're going to continue, but I want to go back here now. Unit circle, this is 1 unit, yes? But I'm going to use this 2 because we have the 2 so I can show you how it gets down to 1. Got it? Okay, so the point right here, if we use 2 for a radius because we have 2 up here, so your brain goes, oh, my radius is 2, correct?
Yeah.
So this point would be what over here? Wouldn't it be 2 comma 0?
Yeah.
Okay, so it's 2 comma 0 is the point, is the xy. But I want it cosine sine. Well, cosine is x over what? The radius, which is 2.
Is it okay if you put
One.
them flip
One
flop?
up.
Like if you
I
put
thought the
X
radius
on
was
that one
1.
and then cosine
I don't
on
care.
The
Okay,
radius is along the side.
the radius right here, we said it's 2. Because we put that triangle in there. Yes? We have the radius as 2.
Yeah.
I put the triangle here and the ratio across from the 90 degrees is 2.
Yes.
So that would make the radius of this circle all the way around being what? 2. Okay? The unit circle is ratios. So I'm gonna put it's 2, 0. It's the XY. Now I want this to be cosine sine. What do I have to put X over to get cosine?
R.
R. Well, what is R? 2. So it would be 2 over 2,
The 1.
which would reduce to 1.
You want us writing these?
You decide when I'm done writing what you want to put on here. I'm showing you how it's getting to 1. Okay? I'm showing you how that's getting to 1. So now, sine is y over r. So that's 0 over what? 2. And what is 0 over 2? 0. So, do you see how the unit circle has a radius of 2, but when I reduce it down to sines and cosines, it's 1, 0?
Yes.
Not 2, 0? Because 2 divided by 2 is what? 1. So on the x-axis and the y-axis, are those 2's going to reduce to 1? Yes? Yes, sir.
Does each angle have its own cosine and sine?
Yes, each angle has its own cosine and sine. We're going to do those. Okay? So we're going to move to 90 since we did 0. We'll move to 90. Okay? So 90, the point up here is 0, 2, isn't it? Because my radius is 2. That's the x, the y.
At the both of them.
And now if I want the cosine sine, I have to put it over 2. So 0 over 2 is what? 0. And 2 over 2 is 1.
Is the radius always 2?
It's in the unit circle. You will, when somebody, like if somebody asks you what's the radius of the unit circle, you should say 1. Because it's 1 unit. We chose our unit to be 2, but does that make sense? Unit just stands for what your scale is. So we're gonna go to 180.
Negative 2, 0.
So it would be negative 2, 0 would be my xy, but my cosine sine is
Negative 1, 0.
negative 1, 0. Now we're never going to use 2, 0, 0, 2 again. When I ask you what your quadrantal, here's a new word, quadrantal is the quadrants. Got it? If I ask you your quadrantal, 0, 90, 180, 270, 360, you're going to tell me 1, 0, 0, 1, negative 1, 0, and
1. Negative
0, negative 1.
0, negative 1. We are not on those axes going to think about this as 2 because it reduces to what? 1. So from here on out, when you do these, you're going to do 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Because we just reduced those down and we're not going to have to do it anymore. Okay, so I said everything is about reference angles. They make our life a whole lot easier. So we did pi over 6, so we probably should go to 5 pi over 6, correct?
Yeah.
Yeah? Okay, so 5 pi over 6, we're going to make that triangle right here. Well, what do I still have?
30 degrees.
I still have a 30, 60, 90 triangle, correct? So this is still 2. This is still 1. But this is, what axis is this? It's the x, but it's the what x? The negative x. So do I have the same numbers?
Yes.
Yes. The x is negative because it's on the negative x-axis, isn't it? So now we're going to go with, what is my x?
Negative or
Negative square root of 2.
At 3.
Oh, it's 3.
3. It's 3. I just said 2. What is my y?
1.
1. So my xy is negative square root of 3, comma 1. This is my xy. So I want it cosine sine, so I put them both over what? 2, because that is my radius. Do you see how I said, if I know pi over 6, I know 5 pi over 6?
Yeah.
Yeah. It's in the second quadrant. We've already dealt with How do I know that point's in the second quadrant? Well, it's in the second quadrant because it's a negative x and a positive y, isn't it? So you would put, anytime you think cosine, you should think what? X. Anything you think sine, you should think y. Every time. So now we're going to go here. What angle do you think we're in the third quadrant we're going to work with?
740.
Radians.
7 pi.
7 pi over 6. Right?
Yeah.
Okay. I don't want to do everything again. I don't want to make another triangle. I don't. Do I need to? No.
You just need
Because
to
my
learn
reference
that.
angle is still pi over 6, yes? And opposite of pi over 6 would be my y, and it would be 1, correct?
Yep.
And adjacent to it, and I just gave you SOHCAHTOA, which we haven't done. But anyway, my y would be 1, and my, that would be negative 1, yes?
Yeah.
Why is it negative?
Cause it's on a negative x.
Because it's on the negative y-axis, right? It falls.
Yeah.
And then my cosine, which would be x, would be what? Negative square root of 3. Now that's my x, my y, and I'm going to put them over what? 2.
And the last.
Is it exactly the same?
No, because it's negative.
Well, but the numbers are exactly the same,
Well,
yes?
yeah, but then
The only thing you need to worry about is the quadrant. Quadrants should be easy to remember, shouldn't they?
Yeah.
So try, what angle are we going to do in the fourth?
11 pi.
11 pi over 6. So try 11 pi over 6. Now, Shelby and Ron, you guys know SOHCAHTOA. This is SOHCAHTOA, right? So if your brain wants to think SOHCAHTOA, use SOHCAHTOA because that's what we're using. We just haven't done. All the rest of you should have done SOHCAHTOA in geometry, but theirs is more recent. Okay, so what's my x going to be? Square root of 3, and it's going to be positive, correct?
Yes.
Because I'm on the positive x-axis. What's my y going to be?
Negative.
Negative 1, because it's on the negative y-axis. And now that's my x, my y. Now I want to make it cosine sine.
Just put it over.
Over 2.
Put it over 2, because 2 is my radius.
Boom.
So now that took a long time. I don't think 45 is going to take as long, do you?
No.
Nope. Okay, so 45. I'm going to make a 45-degree triangle right here. Yes?
Yeah.
Yep.
And so this angle is 45. Well, opposite of 45, my ratio is the square root of 2. And down here would be the square root of 2. And my radius is what?
1.
3.
My radius is
Still 2.
2. 90 is 2. Okay, now do you see why I made you take a 1, 1, square root of 2 into square root of 2, square root of 2, 2? Yes. Okay, so now I'm going to do the same thing. My x is what?
Like square root of
Square root of 2. My y is what?
2. Or 1.
Square root of 2. There's a lot up there.
Both over 2.
Yes?
Yeah.
Okay. So, square root of 2. I have cosine, I have sine, the xy, I want cosine sine,
Put them both over 2.
put them both over 2. So, square root of 2 over 2 is your sine and cosine for 45 degrees. What other angles does that apply to then?
All the other ones. 135.
What, radians?
3 pi over 4.
3 pi over 4,
5
5 pi over 4,
7
and
pi over 4.
7 pi over 4. What is the only thing that's going to change?
Which one's positive?
Which one's positive and negative? What is going to be negative in the second quadrant? The x, so that makes what?
Negative.
Cosine? So square over 2 over 2, and square root of 2 over 2. And what about down here?
Negative.
Negative, negative. And what about over here?
Positive.
Positive. Negative. How am I deciding my positive and negatives?
Quadrant.
The quadrant, the x and y axis. I keep saying that because people will go, I don't understand how to do negatives. The quadrant, the x axis, the y axis. Now, I know we're rushed for time, but I don't think this next one. The next one is 60 degrees. Is that the same triangle as the 30, 60, 90?
Yeah.
Yes. But we're going to have 60 down here. Yes?
It's just gonna be flipped.
So it's square root of 3, and it's 1, and it's 2.
So it's
So the x on 60 is
gonna be
1, and the y on 60 is
Square root of 3.
square root of 3, and over what?
2.
2. What's 2 pi over 3 going to be?
Negative 1.
Negative 1 over 2.
2. And then the square root of 3 over 2.
Uh-huh. And what about
Negative, negative.
negative, negative? And what about
Positive, negative.
positive, negative? Now, go as far as you can on your homework. A lot of them are going to be using this. You can use your circle tonight to do this, okay? But when you're using your circle tonight, please remember you have to know these. You have to know the sign of 1/2. Sign of 30 is 1/2.
Yep.
So use your assignment to help you. Just get as far as you can. We will finish tomorrow.
No.
No, I forgot.